Well, here we have a pretty typical accumulation problem. And so when you look at this problem, you immediately notice that you've got sewage, lovely, entering a tank at this function. And notice it's gallons per hour. So that is a rate function. And I'm going to put this in my F1 function in the graph mode. And be very careful, it's closed interval, 0 to 4. Now, treated sewage is removed from the tank at a constant rate of 645 gallons per hour. Now, I could put that in F2 if I like. And remember, this is removing. So you have to keep it clear. And then this is entering. Okay? So now let's take a look at the first problem. Oh, the other thing, the treatment tank is empty. So that's nice. Our initial condition is 0. So the first question is, how many gallons of sewage enter the tank between 0 to 4? Well, since I have the rate of change for entering the tank, we know that if we take the integral of a rate, we'll get the change in value. So we're going to take the integral of E of t dt, and it's going to be from 0 to 4. So the integral of a rate will be the change in value of gallons. And when you type that into your calculator, you should get 3,981 point something, 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 something. Now, this was a real big bummer because some of you did not answer the actual question because the question said round your answer to the nearest gallon. And so you gave your answer in a decimal format with decimals beyond the nearest gallon. The correct answer then, if you rounded it, would be 3,981 gallons in the sewage treatment tank after 4 hours. If you did not round to the nearest gallon, unfortunately, you did lose a point. So you got +1 for setting up the integral correctly and +1 for getting the correct answers. Okay, let's move on to part B now. Now, part B, you are asked at what time t is the amount of sewage. So that means entering and removing the greatest. Aha. So that means we need to find a maximum. And how do you find maximums? You look at the endpoints and the critical points. Okay, so our endpoints are going to be 0 and 4. And now we have to find the critical points using our calculator. So we know then, if we're looking at the amount of sewage, so let's just say S of t represents the amount of sewage in the tank. The amount of sewage in the tank, well, we know the rate of change of the amount, right? So we know the rate that it is entering, and then we know the rate that is being removed. Okay, those two values are given to us. So in order to find the critical points, then we need to set this rate equal to 0. Okay, now E of t is that big long function, right? And we know R of t is 645 gallons per minute. So therefore, we want to find out when is E of t equal to 645. Now, if you graphed, like I suggested earlier, if you put this into function 1 on your calculator and this into function 2 on your calculator, you're just going to find the intersection points between 0 and 4. So when you do that, you should find 2 intersection points. The first one is at 2.309, and then the second one is at 3.559. Great. So if you've done this so far, you've already earned half of the credit. Now we have to determine which one is the maximum and the minimum. Well, we do know at 0, they told us at the beginning of the problem there were 0 gallons. And we just found out, well, no, we didn't. Actually, let me hold that caboose right there. So let me erase this so I can get more space here. Yeah, sorry, my eraser is not too big on this iPad. Okay, so now I've got to find the values, the amount of sewage in the tank at each of these times. So to find the value, I'm going to go 0 to 2.309, and I'm going to take the integral of the rate of change, which is E of t dt, and then minus 645. Okay, now I'm sorry, I don't know why I put a 0 there. So it's 645 gallons per hour. And so then we know that the 2.309 is how many hours it's been in. Okay, so notice this is one integral. So that's the amount that is being removed. Okay, and then now we've got the amount here that is, I'm sorry, this is the amount that's entering, this is the amount that's being removed. And so when we do the math, we would end up with 1,637.178. Okay, so that's this value. Now we have to repeat this process for the other values. Sorry, my decimal. Okay, so now when I'm going to do that, I'm going to go 0, let's do the same process, but I'm going to go 0 to 3.551. Okay, and that would be the amount of the sewage that has entered the tank, subtracting 645 from 3.559. Okay, because that is the amount then that has left. And so that number is 1228.520. So you can see what I'm doing here is I'm justifying. This is the justification problem, justification process to prove which value is the maximum. And then I do the repeat thing for 4. In that answer, we know that the total amount that's entered, because we did this in part A, is 3,981.022. And then it would be minus 645 times 4. And that comes out to 1,401.022. So now I can clearly see that the maximum occurs at 2.309 hours. So I would say what the amount is, because they want to know the maximum amount. So the maximum amount of sewage is 1,637.178 gallons. And I can say this is the maximum because I looked at the endpoints and the critical points, and this is the maximum value. Okay, the last part. Okay, part C. Now you are asked to find the cost of treating the raw sewage. Okay, fantastic. So if I move this up, give myself a little more space. And so we are told that the cost is this function here per gallon. So basically we have the cost per gallon, and notice it's the cost of processing, of course, what enters, and the closed interval 0 to 4, and also again I want the nearest dollar. So what I'm going to do is I'm going to take the rate at which it's coming in, which is E of t dt, and I'm going to I'm sorry, I don't need to put the dt there because I'm going to put that at the end of the integral. My apologies. So I'm going to take the rate at which it's entering multiplied by the cost, 0.1, the cost per gallon, 0.02 t. Now when I take the integral of this, then I would find the total cost. So I'm going to go the integral of 0 to 4 of this integrand. Now the biggest mistake I saw here is where students would write it as a product. So you would write E of t dt, and then you'd write multiplied by 0 to 4 of the cost, 0.15. Now this is not allowed because we don't have a product property of integrals. We do have a sum, so like you learned that if it was E of t plus 645, I could have separated it into two sums of integrals, but I am not allowed to separate the product. That is not one of the integrals of the properties of integral properties. So once I take the integral of is e to t times the cost, the value would be 474.320. Now it did ask to round to the nearest dollar, so the answer would be $474.